Warm greetings and very good morning to all of you. Today I am going to have a lecture video on shear force and bending moment in the case of beams. All of you know that when the beam is loaded with the different type of loadings like concentrated load, uniformly distributed load and uniformly varying load also with the different end condition of the beams like simply supported beam, cantilever beam, overhanging beam, fixed beam and multi-span continuous beam. Definitely the beam is going to bend in the direction of the applied load. If you are applying load in the case of a downward direction, the deflection will be in the downward direction. If you are putting the load in the upward directions, definitely the deflection will be in the upward direction. So due to bending, you will get both slope and deflection at the required points of a given beam. And what about the shear force and bending moment values for the given load conditions? First of all, what is the shear force and what is the sign convention? Shear force is defined as the algebraic summation of all the forces including the constraint, that is the reaction, either to the left hand side of the section or to the right hand side of the section. For example, so this is a simply supported beam having a support at this end and support at the other end. And it is loaded with the point load at the center, exactly at midspan. So total length is capital L, midspan is L by 2 from either side of the support. So here the load is, I can call it as say 10 kilonewton at the center of the span of the beam. So what will be the reaction at the support ends? Being a symmetrically loaded beam, assume this as a beam which is of say 4 meter, load is applied at 2 meter from the left support and from the right support. So 10 kilonewton downward load, so the reaction will be equally shared the load. So 10 by 2, that is 5 kilonewton upward, here also 5 kilonewton upward. So now I want to take at a distance of 1 meter, what will be the shear force? So here reaction and there is no load up to this. So the algebraic summation of all the forces, that is in the first half, A, C and CB, this one. So here only one reaction. So it is 5 kilonewton upward. Then we have to use the sign convention of shear force. In the case of sign convention of shear force, left up of the section and right down is positive shear force. Towards the left hand side of the section, upward force are positive. Towards the right hand side of the section, downward force is positive. If it is in the vice versa, that is left hand side of the section, downward load and right hand side of the section, upward load. So that is negative shear force. So that is the sign convention for the shear force. Now the algebraic summation of all the forces to the left hand side of the section I am taking. So only one reaction, that is upward, which is positive shear force of 5 kilonewton. Similarly, if you are able to find the just to the left of point load of 10 kilonewton, the shear force value is constant, which is of 5 kilonewton. Then suppose I am just to the right of the given point load of 10 kilonewton. So now I am taking this section here. What will happen? Since the upward reaction and downward load of 10 kilonewton. So left cross section upward is positive 5 kilonewton minus. Why? Because left side down is negative shear force. So 5 minus 10, we are getting minus 5 kilonewton. So just to the right of the given point load, it changes the shear force from positive value to the negative value, but it is constant to the left AC portion. So you plot above the horizontal line 5 kilonewton, 5 kilonewton. Then it comes to minus 5, right? Left of section plus 5 kilonewton, right of section minus 5 kilonewton shear force. And at this support to the point again it is minus 5 kilonewton. So it is of the rectangular, which is of a positive value from first half 5 kilonewton to negative value of shear force of minus 5 kilonewton. So that is the shear force value, right, for the entire beam of AB, and the central point load is at C, that is 10 kilonewton. Similarly, you can able to draw the shear force diagram. So shear force diagram is you have to draw a horizontal line AB. So a plus shear force will be plotted above the horizontal line. Negative value will be plotted below the horizontal line. So here positive 5 kilonewton at the center, minus 5 plus 5 to minus 5, then you will get a negative 5 kilonewton at the support. So from the first half plus 5 kilonewton, the second half is constant of negative shear force of 5 kilonewton. So this is about the shear force calculation for a given simply supported beam of 4-meter span and of central point load of 10 kilonewton, and we have taken the support reaction because symmetrical load, the reaction will be of 5 kilonewton each on either support A and B. Similarly, in the next video we can go for the bending moment values and what are the sign convention for the bending moment of this simply supported beam with the 10 kilonewton. Um, Thank you very much for patient listening. God bless. Walka Vijagam. Walka Valamudan.